This module will talk about different types of foundation systems for homes and how they're insulated. We'll take a look at slabs on grade, concrete block foundations, and precast concrete foundations. And we'll also take a look at some images and pictures of basements and details that can help you get a clue about how foundation systems are built and how they're insulated. So the most common form of foundation type found in homes is the basement floor, which is also called the slab on grade, and it's called that because we literally pour the concrete on the ground. This detail has some added features, and you can see here this is the ground. Here's a couple inches of a under slab insulation, and these tubes represent heat tubes, which are increasingly being added to floor systems as a nice way to provide heat into a home. And here you would have the wall foundation around the perimeter. This is a typical detail of a slab on grade, which is the most common type of basement floor construction method. And again, this detail shows integral composite piping for in-floor heating. A very common type of foundation wall construction that is accompanying that slab on grade is concrete block. And we use quite a lot of concrete block in many different regions because it's fairly easy to build. It is labor intensive, but we can go pick up some concrete block at the store, we can cut it, and it's fairly flexible, and it does go together pretty quickly and at a fairly low cost in most cases. It does need to be sealed with a moisture barrier and insulated because concrete itself is not a good insulator. So here you see the wall that's been started to come out of the ground and be above grade, and a black roll-on type of moisture barrier to keep water from penetrating into the surface of the basement. Another less common but highly effective form of a foundation wall construction is precast concrete, and one of the advantages of this is that the wall sections are made in the factory, and it can be very high quality, delivered to the site and assembled fairly quickly, and a lot faster than a concrete block wall could be built. And they typically have the insulation and moisture barrier built into them, and this also saves a lot of time on the construction site. So it's a more expensive product, but it can save time, and in some cases that's the main reason that it's used. Taking a look at the inside and of a home and additional images, you can see that the precast easily accommodates some odd shapes and can come with insulation and wall studs, making it very easy to build a finished basement later on. Let's take a look at some pictures of basements and other foundation systems to get a feel for some things that you might be looking for as you do a home energy inspection. So in this case we have an unfinished basement, and in this case the basement is not considered to be inside the thermal boundary, and as a result should have some insulation in the ceiling, but if you look you can see that there is no insulation between the floor joist above, and that would be a problem. Also, in an unfinished basement like this, you'd probably look to see if there's some venting that would allow any moisture that could that enters into the basement through the walls and the slab to evaporate and escape. Here's an image of a conditioned basement where the insulation is being added, and a vapor barrier is also being included to help prepare the basement to be included in the conditioned space of the home. So included inside that barrier, and accordingly steps taken to insulate and manage moisture. Here's a picture of a nice finished basement. Looks like there's plenty of room for a pool table there, and increasingly this is how homeowners will improve their home over time, is they'll take that basement, add insulation, frame it out, and finish it for part of the additional conditioned space of their home. Another more nasty place that we create in the way we build homes is a crawl space. This is generally not a lot of fun to work in, and because of that sometimes work doesn't get done well. The insulation or the installation of materials, insulating pipes and ductwork not getting done well, and because sometimes these spaces are hard to get to other than by animals who might get in there and make a home, damage to insulation or ductwork can often go undetected for a long period of time. So we'll definitely be peeking into crawl spaces if we can get to them to see if we can see anything that needs to be repaired. Let's take a look at different types of foundation insulation methods and locations, and we'll go back to our cross section of a home. But first, keeping in mind that we may need different types of insulation at different locations because there's different types of conditions that exist. Often also remembering that we are combining, in this case, the insulation with water and vapor barriers. It's safe to assume that in older homes, if you can't see it, it's very likely missing. But in newer foundations, we typically have better methods of insulation. We'll also take a look at some of the funky details where we're very likely to be missing insulation. So back to our cross-section of a home, and zooming in on the basement part of the home, some important locations that we'll be taking a look at are the rim joist, where the first floor meets and rests upon the foundation wall, because this is often a space where we're missing some insulation and it's also easy to add it. We need to take a look at our foundation walls and to see, especially if the basement is conditioned, whether or not there's insulation there, and our floor systems, or our slab on grade or dirt floor in a crawl space, to see if there's any insulation in these spaces. Some different ways to accommodate this insulation. As we saw on the previous image, we typically insulate slabs by putting down some rigid foam insulation before we pour the concrete, and usually also add a vapor barrier to keep out moisture. Looking at our foundation walls, the easiest way to insulate these is to add foam on the outside surface of the wall, and this typically rigid R5 foam, and also combined with waterproofing, as we saw in the earlier image. If we've got an older home and that insulation wasn't put in place, the typical option is to add the insulation to the inside of the basement, and in this case we typically frame out the wall to build some room for the insulation, and we're probably on our way to building a finished basement. If we have an unconditioned basement, the location of insulation will be in the ceiling above the basement, and this is either done with fiberglass or foam, and it also, as we have seen, will move that thermal barrier to the floor frame and therefore have an unconditioned basement. So pretty important to detect if that basement is finished or not, because that will tell you whether or not you should be looking for insulation in the ceiling of the basement. To review some important locations, we talked about the rim joist, where the first floor rests on the foundation wall, the location where the wall meets the foundation. Walls to crawl spaces are important places to look, as well as knee walls, where we might be looking for vents or also some additional insulation or opportunities to help seal up a home. So you might say, well, how do I tell if there's insulation behind that wall or underneath that slab? Well, one of the things you can do is ask the homeowner, and they might know. They may have been around when the home was built, or they may have some drawings or understanding of what was there. You can obviously go into the basement and inspect for insulation. It's a good place to look, and check those rim joists and walls to crawl spaces. Those are commonly places where it's easy to add insulation. And also just check the temperature. If they refer to the basement as a conditioned space, but it's very cold, it might be a clue that there's insulation missing from the foundation walls, and you might want to add some. Also, if you can't see it and it's an older home, it's probably a good assumption that it isn't there, and older homes are often more likely in need of additional insulation.